transversal. Let us take two or more given lines. The lines that intersects the given lines in different points is called as transversal. One. As shown in case 1, L and M are intersecting lines. These lines are intersected by a transversal and at two different points A and B. 2. As shown in case 2, P and Q are parallel lines. These are intersected by a transversal R at two different points X and Y. Concurrent lines. If three or more lines intersect at only one point, then such lines are called concurrent lines. Kinds of angles. Right angle. In the adjoining figure, angle AOB is equal to 90 degrees. We call the angle measuring 90 degrees as right angle. Acute angle. In the adjoining figure, angle AOC is 60 degrees. This one is less than 90 degrees and greater than 0 degrees. If the measure of angle is less than 90 degrees and greater than 0 degrees, then such angle is called an acute angle. Obtuse angle. In the adjoining figure, angle AOD is equal to 140 degrees. This measure is greater than 90 and less than 180 degrees. If the measure of an angle is greater than 90 degrees and less than 180 degrees, then such an angle is called obtuse angle. Straight angle. In the adjoining figure, OB and OA are mutually opposite rays. Angle BOA is equal to 180 degrees. Angle BOA is called a straight angle. If the measure of an angle is 180 degrees, then it is called straight angle. Reflex angle. In the adjoining figure, four angles formed are angle AOC, angle COB, angle AOB and angle BOA. We know that angle AOC is 180 degrees, angle COB is 50 degrees. Therefore, angle AOC plus angle COB is equal to 180 degrees plus 50 is equal to 230 degrees. Angle AOB is formed by combining angle AOC and angle COB. That means angle AOB is equal to angle AOC plus angle COB is equal to 230 degrees. We know that angle AOB is greater than 180 degrees and less than 360 degrees. Such angles are called reflexive angles. If the measure of an angle is greater than 180 degrees and less than 360 degrees, then such angle is called reflex angle. Complete angle. Angle AOB plus angle BOA, this is the sum of two straight angles. We know that the measure of each right angle is 180 degrees. As this combination is sum of two straight angles, the measure is 180 degrees is equal to 360 degrees. That means the value of complete rotation is 360 degrees. Therefore, 360 degrees measure is called complete angle. If the measure of the angle is 360 degrees, then it is called complete angle. Zero angle. If the angle measure is 0 degrees, then it is called zero angle. Triangle. A simple closed figure formed by three line segments is called a triangle. We know that in the adjoining triangle ABC, AB bar, BC bar, CA are the sides, A, B, C are the vertices, angle ABC, angle BCA and angle CAB are its angles. Equilateral triangle. The triangle with all the three sides measuring equal lengths is called an equilateral triangle. Each of its angle measures 60 degrees. Isosceles triangle. A triangle with two sides of equal measurement is called an isosceles triangle. In an isosceles triangle, the measures of angles opposite to equal sides are equal. Scalene triangle. The triangle in which no two sides measure equal is called scalene triangle. Right-angled triangle. If one of the angles of a triangle measures 90 degrees, then the triangle is called right-angled triangle or right triangle. Acute-angled triangle. If every angle of a triangle is an acute angle, then such type of triangle is called acute-angled triangle. Obtuse-angled triangle. If one of the angles of the triangle is obtuse angle, then the triangle is called obtuse-angled triangle. Quadrilateral. The closed figure formed by three line segments is called a triangle. Similarly, we also know that the closed figure formed by four line segment is called quadrilateral. Types of quadrilaterals. Trapezoid or trapezium. A four-sided figure, quadrilateral, with only one pair of parallel sides is referred to as trapezoid or trapezium. Isosceles trapezium. A trapezium in which non-parallel sides are equal and is called an isosceles trapezium. Parallelogram. A parallelogram is a quadrilateral in which the opposite sides are two pairs in parallel. Rectangle. A rectangle can be defined as a parallelogram in which all angles are right angles. Square. Square is a rectangle in which all sides are equal. Rhombus. Rhombus is a parallelogram with equal sides. Kite or deltoid. Kite is a quadrilateral in which the measures of each pair of adjacent sides is equal. Polygon. A polygon is a closed figure formed by three or more line segments. Observe the following figures. One. It is a polygon with five sides. We call this as pentagon. This is a polygon with six sides. We call this as hexagon. This is a polygon with seven sides. It is called as septagon. This is a polygon with eight sides. We call this as octagon. Polygon is called regular polygon if all sides are equal and all inner angles are equal. Identification of three-dimensional figures. Cuboid. The solid having the four lateral sides with base and top are in rectangular shape is called cuboid. The solid formed by six rectangular surfaces is called cuboid. Cube. A solid formed by the enclosure of its six square plane surfaces is called a cube. Cube also has 6 faces, 8 vertices, 12 edges. Cylinder. The adjoining figure refers a cylinder. Its base and top are circular in shape. The remaining surface is called curved surface. Cone. Its base is a circle. Its radius is denoted by R. AC bar is called slant height and it is denoted by S. AO bar is called vertical height and it is denoted by H. A is called its vertex. Sphere. Ball, marble and balls in a cycle bearing are some examples of sphere. AO bar is called its radius. Its surface is called curved surface. Prism, triangular prism. The adjoining figure shows a triangular prism. It is so called according to the shape of its base. It is a base triangle. It has 5 surfaces and 6 letters. Pyramid. Their base is in square shape and their lateral faces are in triangle shape, such that all the 4 surfaces meet at one point. The adjoining figure shows a pyramid with square ABCD and its base. AB bar is equal to BC bar is equal to CD bar is equal to DA bar is equal to A. Shows the sides of its base. EO bar is equal to H has H is called its vertical height. Angle EC is equal to S. It is called its slant. Height or lateral height. Triangular pyramid. If a pyramid has triangular base, then it is called as triangular pyramid. It has 3 triangular lateral surfaces and 1 triangular base. Altogether, the triangular pyramid has 4 triangular faces. Making of 3-dimensional objects. Rectangular solid or cuboid or rectangular parallel piped. Procedure to make cuboid. 1. Take a cardboard and cut it as shown in the figure with the measures EF bar is equal to HG bar is equal to DC bar is equal to AB bar is equal to length. FG bar is equal to BC bar is equal to AD bar is equal to EH bar is equal to breadth. And BF bar is equal to CZ bar is equal to AE bar is equal to DH bar is equal to height. 2. Fold along the lengths HG bar, DC bar and AB bar and breadths BC and AD. 3. Fold at DC bar and HG such that EF bar of rectangle EFGH coincides with EF bar of rectangle EFBA as shown in the figure. 4. Fold along BC bar such that the breadth FG bar of the rectangle EFGH coincides with the length of FG bar of rectangle CBFG. 5. Also fold along AD bar such that the length EH bar of the rectangle DAEH coincides with the breadth EH of rectangle EFGH. Now the required cuboid box is formed. Cube. Take a cube made up of a thick cardboard and cut along the dotted lines as shown in the figure. Procedure to make a cube. 1. Take a cardboard and draw 6 squares with convenient length. 2. Fold cardboard at sides HG bar, DC bar, AB bar, BC bar and AD bar. Fold at DC bar and HG bar such that the sides EF bar of the square EFBA coincides with the side EF bar of square EFGH as shown in the figure. 4. Fold at BC bar such that the FG bar of the square CBFG coincides with the side FG bar of the square EFGH. Also fold at AD bar such that the side EH bar of the square DAEH coincides with the side EH bar of the square EFGH. Now forms the required cube. Making of a cylinder. 1. Take a rectangular piece of paper ABCD. 2. Make its round fold such that corner C should coincide with the vertex D and get corner B with corner A along the breadths. Now the formed shape is called cylinder. Its base and top are in the shape of a circle. Its side face is curved. So this is called curved surface. Recall where and when you have seen cylindrical objects. The round pencil we use. The blowing pipe used for blowing during cooking pipe of water tap, bars of windows. Rod leveling roller. The ruler being used to draw lines on white paper by old people like our grandfather, etc. Making of a cone. 1. Take a sector shaped white or any colored paper marked as OAB. 2. OA bar, OB bar or its radii. Now roll the paper in such a way that the point B coincides with the point A and edge OA bar coincides with the edge OB bar. Now you get the shape as shown in the adjoining figure. This is called a cone. Its base is in the shape of a circle and it gradually gets diminished and sprout as a point. This is called the vertex. Recall where and when you come across such shapes: ice cream cones, polypack, grain heaps, etc. Tetrahedron. Making of a tetrahedron. Draw an equilateral triangle PQR and draw isosceles triangle or equilateral triangles PQU, QRS and PRT on the sides of PQR. Fold along PQ bar, QR bar, RP bar. Then form the triangles PRT and PQU. The side PT bar coincides with PU bar from the triangles, from the triangles PRT and QRS. The sides TR bar and RS bar coincide, and likewise the sides QS bar and QU bar of the triangles QRS and PQR. 4. The vertices T, U and S coincide with one another. Let us call this vertex apex as O. Now the so required tetrahedron is formed. Symmetry. The presence of identicality and isomorphism imbibed in their shapes only that causes such a good feeling in us. This character itself is called symmetry. In daily life, we use the term symmetry more generally. The two-dimensional shapes like rectangle, square, rhombus, circle, etc., sand clock, butterfly, tumbler, pot, etc. are symmetrical objects. Symmetry, reflection. The reflection caused by mirror and line of symmetry has natural relationship. Observe how the letter A appears in the mirror as shown in the figure. Draw a line L along the edge of the mirror when erected on the paper as shown in the figure. With respect to this line, the figure so formed in mirror is symmetric. The important point is that there is no difference between the shape of the original figure and reflected figure. The angle also will be the same. Only one difference, what it is. Kaleidoscope. Take 3 rectangular mirror pieces, arrange 2 into V shape, facing the reflecting surface opposite to each other. Arrange third one on the V shape so the 3 mirrors are in a triangular shape. The faces of all the mirror surfaces are facing each other. Close one end of such arrangement with triangular shaped mirror with the reflecting surface inside or a thick cardboard. After dropping colored glass pieces from the other end, close this end with triangular shaped transparent glass piece. Look through the glass piece by shaking the instrument now and then. Constructions. Construction of a line segment. Let us examine the steps in constructing a line segment of given length. 1. Mark A at 0 on the scale. 2. Point B is to be marked at the place where the length of the given line represent on the scale. For example, let us construct a line segment of length 5 cm. We should mark B at a distance of 5 cm on the scale. 3. Move the pointer of pencil along the edge from A to B. That means the points A and B are joined. 4. Now the line segment of length 5 cm is formed. Construction of circle. We construct circle with the help of compass. To construct a circle, radius and a point are needed. Procedure of constructing a circle. 1. On the plane surface, mark point O. We consider this as center of the circle. The line segment obtained by joining the center of the circle and point A on its circumference is called radius. 2. Take measure of some radius with the help of a compass, for example 2 cm of radius. 3. Draw a circle with center O as shown in the figure. Perpendicular bisector. Draw a line segment of 5 cm with the help of a scale. 2. Draw 2 arcs below and above the given line segment with center A and radius more than half measure of the given line segment. Example, radius greater than 2.5 cm. With the same radius, draw 2 more arcs to cut previous arcs from B as center. Draw a line L joining the intersecting points of the arcs. The line L itself is the perpendicular bisector of AB bar. P is the midpoint of AB bar. That means AP bar is equal to 2.5 centimeters, PB is equal to 2.5 centimeters. Therefore, AP is equal to PB is equal to 2.5 centimeters. Construction of an angle. Let us construct an angle of 30 degrees. 1. Draw a ray AB, A to B, repeat. 2. Keep the protractor on ray AB such that its center coincides with A. Adjust the protractor such that its 0, 0 line exactly align with AB ray. 4. Starting from 0 on the side of B on AB ray, count 30 degrees and mark a point C there. Remove the protractor and draw AC ray. Angle BAC measuring 30 degrees is formed as required. When the angle measure is known, we can construct the angle as shown above. Construction of angles measuring 60 degrees and 120 degrees using compass. You learnt the construction of any angle with given angle measure by using a protractor. Observe how certain angles can be constructed by using compass but not with a protractor. Construction of an angle of 60 degrees. 1. Draw AB ray. 2. With A as center and convenient radius, draw an arc intersecting AB ray at C. 3. Without altering the radius, draw one more arc with C as radius to cut the previous arc at D. 4. Draw AD ray by joining A and D. 5. Angle BAD is formed with 60 degrees as the required angle of measure. Construction of an angle of 120 degrees. 1. Draw a ray AB ray. 2. With A as center and convenient radius, draw an arc cutting AB ray at C. Without altering the radius, draw another arc with C as center to cut the previous arc at D. Again, without altering the radius, draw one more arc with D as center to cut the first arc at E. Draw AE bar joining A and E. 6. Angle measuring 120 degrees is formed as angle BAE. Constructing an angle congruent to the given angle. Let us examine the construction of given angle for angle 35 degrees with the help of compass. Let us say angle ABC measuring 35 degrees is the given angle. Draw PQ ray. 3. Draw an arc with convenient radius by using compass and B as center to cut BA ray and BC ray. the arms of given angle, angle ABC at D and E respectively. Four, without change in the radius drawn, an arc with P, the end point of ray PQ, as center to cut the ray PQ at Z. 5. With the radius equal to DE and Z as center, draw another arc to cut the previous arc at H. 6. Draw PH ray joining P and H, measuring angle QPH. With the help of the protractor, you will need to repeat. You will notice angle QPH is equal to 35 degrees. 7. Angle QPH is equal to given angle ABC. Drawing perpendicular from the given point on the given line. 1. Draw a line L. 2. Mark a point P on the line L. With pass center and with convenient radius, draw an arc to cut the line L at A and B. With A and B as centers and with a radius more than the previous one, draw two more arcs intersecting each other at Q. Draw PQ ray by joining P and Q. PQ ray will be perpendicular to L. You can verify it with the help of a protractor. Drawing perpendicular line through a point which is not on the given line. 1. Draw a line M. 2. Mark any point A that does not lie on the line. 3. With the radius more than the perpendicular distance from A to M and with A as center, draw an arc to cut the line M at P and Q. With a radius more than the previous radius, draw two more arcs from P and Q to intersect each other at B. Draw a line N joining A and B. 6. Now, line L and line N are perpendicular to each other. Draw a line parallel to given line through a given point. 1. Draw a line L in a plane and mark a point P which is not on L. 2. Draw a line M through P cutting the line L. 3. Mark the intersecting point of L and M as Q. 4. With convenient radius and Q as center, draw an arc to cut L and M at R and S respectively. With the same radius and P as center, draw another arc to cut M at U as shown figure. 6. With the radius equal to RS bar and with center U, draw another arc to cut the previous arc at V. 7. Draw a line N joining P and V. 8. L and N will be parallel to each other.